This conference will now be recorded.
Thank you. um, and anything with the Feather River is state water project. Anything with state water project is state water contractor funded. And so with the pilot program, as you'll see, it was really to be accountable for, is this program, ASO, is it really something that can work in a non-traditional snow-bearing watershed? There's snow in the Feather River, but it's a rain-driven watershed. It's not the Airborne Rain Observatory, so understandably, there's a lot of skeptics, right? And so I think we're really proud of the results, and so we'll dive into that and get a little bit into the modeling. I'm not going to do too much of a technical dive because I've got smarter people that do that, and I'll probably embarrass them if I try to get too far into it, and then get into some of our recommendations. So the California Cooperative Snow Surveys program, it was established in 1929 by the California Water Code. And the department has several things that are tied to the water code, but in hydrology world, for what we do, forecasting, section 228 is one of those. We have and by the way, 1929 does predate the department. So that was the Division of Water Resources way back then. There was another program that's now in DWR that was established in the same year. It was the Safety of Dams program. I like to say that theirs was a disaster. Ours was a cool thing because people like snow. But as you can see there in the language, the language is pretty antiquated. Forecast of the seasonal water crop, right? How much water is in the snow? And we can either do it ourselves or the nature of the name of the program, Cooperative Snow Surveys. We don't do it alone. There are dozens and dozens of agencies across the state that contribute in one form or another. Several of them go out and measure the over 260 snow courses that we have. They're doing it this week. Some contribute funds to make that happen. Some do both. So in-kind services plus the manual labor really is what makes up this program. This is an amazing program because it truly is cooperative. We have meetings every week on the ASO program. We have regular meetings on the regular snow survey program, a big annual workshop that we put together. And it is a complete sharing of ideas. Egos are thrown out. It's just amazing. And it's hard sometimes to picture that in the water world, right? I mean, there's always eating interests and people are smarter or better at what they do and where's the money. This program, there's almost no egos. That's why I'm so attracted to it. So the Alps now, the Sierra Nevada is the birthplace of modern snow surveys. We like to claim it in California, but technically it was in Nevada over in Mount Rose. Not by one of us. Not by one of us cool engineer hydrology people. By that guy, Dr. James Church, who was a professor at the University of Nevada, Reno in classics. I'm not really sure what classics are. I imagine it's a lot of books. But Dr. Church had this notion that, if you could figure out how much water was in the snow, you might be able to figure out how much runoff would occur when it melts. So the bonus question is, why was he so motivated to do this? And by the way, Mount Rose was not his first choice. He thought, I'll create a wintertime weather observatory on the town of Mount Whitney at 14,000 whatever feet. The classics professor. He quickly realized that for him to get anywhere, it wasn't going to be 14,000 whatever feet. So the motivation was, as I kind of alluded to, well, if you know how much water's in the snow, you'll know exactly how much runoff there is. The motivation was there was a lot of fights and wars over the Truckee River water. Living in Reno, hey, this spoke volumes to him. So he had this claim that if you could establish a series of snow courses, Mount Rose was the first, several others on the North Shore, Tahoe were number 2, 3, 4, that he could forever solve the water wars over the Truckee River. Right about the correlation, he was wrong about forever solving water wars, but we owe a lot of debt to him. He remained active in this program through the Western Snow Conference until the 50s. He loved where it was going. That was when kind of the first technology of snow pillows was starting to show up. And we still pay a lot of homage to him. We see the ASO as furthering the legacy and creating it here in California where we feel that the birthplace was. So if you go up to Mount Rose, there's that plaque you'll see honoring him. So 1929, we had this water code that said we need to collect all this data and we need to forecast the water crop. So that's the runoff forecast, right? So once the department was actually established in the 50s, along came our Bulletin 120, which is water conditions in California. The primary product that comes out of that is a forecast of the April 1 through July 31st volume. Some people call it the AJ volume, some people call it the snowmelt volume, the seasonal runoff, call it whatever you want. It's how much water we believe is coming off the snowmelt from the mountains, starting on April 1st through July 31st. We do a median forecast. We do a 10% forecast, which is the high end. 10% of the cases should be wetter than that. We do a 90% forecast, which is the low end. Only 90% of the cases should be wetter than that, to kind of bookend the extremes and recognize that there's a lot of uncertainty in hydrometeorological processes. Used to be mostly accountable to the weather. Now with our watersheds, it's everything else, burning, drying, you name it. And we also do a full water year forecast, so October 1st through September 30th. The Bulletin 120 is required to come out on the 6th business day of each month, February, March, April, and May. Checking your calendars, March 10th will be the next first of month forecast. But we do weekly updates as well. So there'll be one coming out this Thursday. So every Thursday there's a Bulletin 120 update. That data is based off the snow pillows, precip network, full natural flow. The first of the month surveys are based off snow course measurements. So there's 260 snow courses across the state. There's about 125, 130 snow pillows across the state, snow sensors, whatever you want to call them. Again, we don't operate all those. The department needs help. The NRCS operates a lot of the snow pillows. Reclamation owns, we kind of maintain a bunch of the snow pillows, and others. The Army Corps has a bunch of the snow pillows as well. But that forecast, as you can imagine, it's called a water supply forecast. We know how the patterns here in California are supposed to work, right? We build up all this snowpack through the winter and early spring, and then around April 1st, we should have our peak. Not thinking that's going to be the case this year. And then it melts off. And so tied to that are reservoir operations. Right? Water control manuals are kind of loosely based on that same pattern. And so they're still very much in a flood control mode right now. They got to keep their pool elevation down, but sooner or later, based on their curves, they can start filling again. Problem is, it doesn't really allow for the dynamic climate that we're seeing nowadays. And yes, we're already seeing melt in the snowpack right now. So did we already have our peak, which would be alarmingly early? Or can March be another miracle March and help us out? We'll see. That'd look great. So that's kind of the background on why we're doing all this work. So as I alluded to, we've been doing this since the 50s. Not me personally. We've been doing this since the 50s. When we didn't have all these cool computer models that could simulate everything from the soil all the way up to the atmosphere and everything else. They use good old regression equations. We continue to use good old regression equations. And yes, they're kind of losing a little bit of their luster because they're not as agile with the changing conditions. But they still have a lot of power. They still give a lot of insight. And those equations were based on three main variables. Snow water content to date, the precipitation observed to date. So if you're making a forecast today, how much rain has fallen, how much snow is on the ground, and then full natural flow runoff, which is a calculated number. Those were the three main variables. There's other things that go into it, little bit of antecedent conditions, some other factors. But again, we recognize that those were slowly losing some credibility simply because it just seems like Mother Nature wants to, every 3 or 4 years, reshuffle the deck on us. I didn't think I would see career highlights stacked up right on top of each other. April 1st snowpack in 2015, 5% of average. Historic low by 20%, like difference. I mean, we shattered the record. I wasn't really proud of that one. 2 years later, we set the new record for the accumulated precipitation in the Northern Sierra 8 station while that thing was going on at Orville. 2 years apart. At that point, I was done with career highlights, but Mother Nature said, hold my beverage. And we went into an even worse drought, 2020, probably the years now, right? 2020 through 2022 or whatever it was, like even worse. Like the snowpack wasn't as bad as 2015, but it was so much more impactful. Wildfire. We burned, 1 million acres and several watersheds during that time. Changed the landscape. And then we had last year, 2023, or 2 years ago, which you all followed the stories on the Tulare Lake Basin. What happened there? Well, that was an almost 250% snowpack impacted by a really severe atmospheric river that dumped all over the Sierra foothills. Those are small reservoirs. And next thing you know, we had a reemergence of the Tulare Lake Basin. I'm really not asking for any more career highlights, but this is what Mother Nature's dealing with us right now. So the need to innovate. We've got all these impacts on climate. You've got the warming climate, more rain instead of snow. Really seeing that this year, especially in the central and southern Sierra. The rising snow line. We've talked about renaming the Snow Surveys program, the Snow Search and Rescue program, at the rate we're going. Increasing the winter flood frequencies. We've seen it this year. We had catastrophic fires in LA, followed a week or two later by record flooding up on the Pitt River. I know it's 2 ends of the state, but if you're in my group that deals with emergency management as well, it's mind-boggling to shift both gears. I mean, who thought we'd have major wildfires in January? So this is impacting, our runoff, and our models and our technology need to keep up with it. Snowfall distribution. That's one of the main motivations behind ASO. So a snow course is a single place in the mountains. Feather River maybe has 20 snow courses, but it's a giant watershed. I mean, you've all driven through the mountains or something, right? You drive up 80 over the summit and you're looking at, oh, there's Boreal and there's always snow there because they're making it. And why is there no snow on that side? Because it faces the sun more. Can you imagine making an entire decision on runoff from that one location when if you just walk to the top of either hill, you would see so much different variations of the snowpack as far as you could see. So either 125 snow pillows or 260 snow courses is just not enough data when the snow distribution patterns are definitively changing, and all you got to do is go over one ridge to another and the snowpack could be completely different. Albedo, how white is the snow? That's important because it reflects the sunlight. It reflects the solar radiation. It's how the snow protects itself from melting. When the snow's been sitting there for a while, it's dirty. Okay, even if we get an inch of snow tomorrow, it'll reset the albedo. It'll slow down the melt pattern for us. So even these small storms that come through may not add a lot of volume of water, but it'll slow down the melt rate. We would love to see some of that. Loss of canopy, fires, leads to increased solar radiation. So it's in changing the melt patterns in some watershed, San Joaquin, the American, Feather, they've all had big fires. Changing watershed behaviors. So we launched into this several years ago now, a roadmap for a climate-informed forecasting framework, recognizing that we need all kinds of technology. We need research partners. We need other partners who can help us keep up with how things are changing. And on the left side of that, you kind of see this idealistic view of hydrologic monitoring with satellite imagery coming in to help us. So that end of remote sensing, the ASO plane, which is not an A6 bomber, but still flying over when we do missions. and then manual course measurements there, as well as the sensor network. All of those still matter. ASO is not here to replace the in situ on the ground measurements. We need verification. We need human eyes on it. An airplane is not necessarily going to pick on water falling out of the tube as you're going to sample it, which happened yesterday. All that information coming into, that actually looks like the JOC, or coming into our academic partners or our federal partners or our local partners. We all share the information. We all discuss the information. There's no hiding and there's no trying to bias decisions. And that's just kind of a view of the sensor network, which we're also going through a major upgrade, because hydrologic models aren't just snow and rain and runoff. Soils, they're everything, right? Everything is on there. So we're trying to find sensors. If you're familiar with like the Snow Lab, Central Sierra Snow Lab, we pay for a lot of their work to keep ahead of us on those kind of technologies. And Andrew up there's doing an incredibly awesome job. So, you know, if you ever get a chance to dive in on his webpage, do so. You're like throwing him $30-40 to do so, because it's those kind of researchers that we need to stay ahead of things. Understand how are these technologies even usable in trying to sense snow or any other hydrometeorological parameter. All right. Besides ASO, like I said, we use satellites. University of Colorado has a program that uses satellites. We like to spy on the snowpack, right? And so this is very useful. It's very helpful. Noah Molich's group does this and provides this to us once a month. So they make an estimate of how much water content is across the Sierra Nevada and the Southern Cascades. The satellite data is great. I kind of think of it as the equivalent of the snow pillow network. It's there. The satellite's always there. If it's a cloud-free day, they can get an image. But it doesn't have necessarily the same technological needs that we have as the ASO does. So spaceborne missions are great. They're just not quite there yet in terms of replacing flying an airplane. But we got a cloud-free day. They can help analyze that for us, and it gives us a good sense. Noah's group at Colorado actually works really closely with ASO Inc. in terms of sharing algorithms and information to kind of dial these two products in, so they're not necessarily competing and arguing with each other. It's a cooperative program. You know, they know each other very well, but we explain to them what a cooperative program means. We don't need competing resources. We need things that help us inform, that are kind of apples to apples as best we can. So what is ASO? Well, it's an airplane that is got a bunch of equipment on it. It's got LiDAR, right? So we need to know the depth of that snow. That's key number one. But it's also got an imaging spectrometer on it that tells us the color of the snow. It gives us all those physical parameters of what's going on. And there's like three main components to it. So in the summertime, we'll refly watersheds every so often because we need that baseline survey. No snow on the ground. What does the ground look like? Typically, we're hoping those data sets can last 5 to 10 years, but if a big fire comes through, we'll reach in the pockets of our sofas and pull out some change and try to fund a new flight to get that new baseline, because it's going to give us the vegetation change. It's going to give us a lot of things. That can be really tough because fires now go into December and we're trying to beat the snowpack, right? So flying the snow freeze become challenging. Obviously, in the wintertime, they flew the Tuolumne today. They're flying the Feather today or tomorrow. So during the wintertime, we will schedule flights with them. It has to be weather friendly, obviously. And we're only limited to so many per year. And that's going to give us, again, the snow depth, but with that spectrometer, it's going to give us a lot of other information as well, which then we're trying to coincide that with manual course measurements so we can verify the density of the snow. How consolidated is that water in the snowpack? Then all that gets jammed into all these models. The ice snowball model, which I'll talk about, I kind of call that the Rosetta Stone. It takes all this super complex information that's coming out of the airplane, and it jams it into a model. It's a snow hydrology model that can actually make sense of it for the rest of us who are trying to make decisions and forecasts based on it. And so it's really interesting. You'll see some graphics about what it's giving us. It's not an A6 bomber. It's a pretty cool plane. But what you see on the right there is when I say we're going to go fly a watershed, they call it mowing the lawn. They literally just fly back and forth like that over the watershed. They're collecting data. We get data points every 3 square meters. So take your 20 snow courses in the feather, but you can also take every 3 square meters and get data. And so it's a really impressive amount of data. It takes them 2 or 3 days to process all of it through the ice snowball and everything and get it to us. But they are out mowing grass today in the Tuolumne, and they'll be doing the feather and the San Joaquin this week, and hopefully the Kings this weekend. Some of our southern Sierra watersheds, the Kings, the Coia, the Kern especially, they are military flight zones. Everybody see Top Gun Maverick? Tom Cruise flew his F-18 through our snow areas. So we have to coordinate with them when they do it for us. Coordinate with the military to get permission to fly in there unless it's the weekend. Usually the military is pretty good about it, but yeah, we tried to fly last weekend and they said, no, we got training. So we're second. We're not quite the Department of Defense. This is the kind of resolution of some of the products we can get out of there. This is back in 2013. This is obviously the upper Tuolumne. You see Hetchy and Eleanor and Sherry there. And it gives us snow depth. It gives us that snow coverage. If you really wanted to peek into it, you can kind of see which ridges are there, even though there's snow all around it, etc. I mean, this is an image, but obviously we're getting the data behind all of this that can feed into these models. It's more pretty to look at images than a bunch of data. Right? And from the ice snowball report, we're getting all these different looks. This is, some rose plots of where exactly the snow really is at what elevation. The one on the left is, for me, it's as a manager, that's really impactful. That's an easy kind of graph to show up management and explain it. These are the different flights at the different elevations. You can see where we've gained or lost snow. And that's an indication of where we're at, what time of the year, and what's going on. And that heat wave we have, you can see at this elevation, it melted snow. That's, Cami, all right. That's pretty easy to explain to a manager who's trying to support us and understand this. The rest of the stuff, they probably fry their brains. But so from these models, we get really easy graphics that we can share up the chain. Who just they only need soundbite. What's going on, right? Versus getting this out to our team and our partners to really dive into the more complex stuff and really trying to understand a little bit more about what's going on. We had a coordination meeting yesterday for our program. There was a big discussion on the fact that we're already seeing melt. Why, where, what? Obviously, it's been warm, but where? Not in every watershed. If that's melt now, that's volume of runoff that's not happening after April 1st. So our April 1st forecast is too high because of early melt. We had a lot of error in 2023 when it was a big water pack year. The volume was over less right, but it happened after August 1st. So sometimes people go, your forecast was so far up, like it came on August 10th instead of July 31st, So you have to dive a little deeper into some of these nuances, especially with these extremes that are pushing our snowpack melt into times outside of the April-July period. So just being able to look at graphics and information and understand it far better than we ever did. This only goes back as far as 2020. The program goes back over 10 years. It started in the Tuolumne River watershed. ASO was launched out of NASA JPL. It truly is a California product. It's now in several states, and it's in a couple of nations too over in Europe. But this picks up the show in 2020 when we were pretty much the Central Sierra, following me down through Kings. And we started to slowly expand. The Quia showed some interest. You see, then all of a sudden we got in the Northern Sierra. Feather, Yuba, American. The Truckee came on board somewhere in there. Truckee and Carson. And then boom, all of a sudden we got all this funding, right? You go back a couple of years and the governor's just handing out money. And we got to expand our program. We tried to take on Lake Shasta. We'll go back someday. It's just so big. And the pit itself is so weird. that it's, the tool works, the models need some time. We'll need to get some local interest in the Trinity. But you'll kind of notice, besides the San Joaquin and the American, there's two watersheds that reclamation is in, Shasta and Stanislaus, that we're not in, and it's been a little bit harder to grab onto them and show them that water matters. And but we'll get there someday. But you see a bunch of these other watersheds, and there's so much local interest and partnerships in those watersheds. And as much as we've advocated for funding and really pushed for the value of this, I've got to hand it to our local partners who have really gone up the chain and argued for this with their boards and everything else. And it's that spirit of a cooperative program. And they're the ones who are constant, like, when's the flight going to be? I'll get people out there to do supplemental course measurements on whatever, what do you need? It's an expensive program. They don't necessarily have the money to fund the program, but they're in it 100% with their advice, their knowledge, and manpower if they can. And then in red, you kind of see, eyes don't work that well anymore. We're kind of limited to 2 to 4 flights per year. Feather has 4 flights per year. It's really 3 flights because the first flight is just an initialized condition. So we'll try to get that before the February 1st Bulletin 120. And then we've got 3 flights left throughout the year. Want to hit one now? Do we want to try to estimate when the peak is? We definitely want one during the snow melt. So 4 flights is really not a lot. We'd like 8, really operationally. And a couple of the watersheds, we only have the funding for 2. We got ice snowbow in all the watersheds that we fly, and then the WRF hydro model, which I'll talk about briefly. We only had funding for a couple of watersheds, the Feather, which I'll talk about, and the San Joaquin were the 2 pilot, and then we expanded. But then you see that sad note at the bottom that, like most state programs, we had to scale back because of funding. So we go from an $11 million a year budget to 4. So next year we have $4 million. We will not get rid of watersheds. We don't want to lose the momentum with our partners. So there's 3 knobs on this program. The number of watersheds is one, the number of flights per year is another, and do we go fully integrated with the WRF hydro model is the third. We're going to scale back the WRF hydro, we're going to scale back the number of flights, but if all of a sudden we stop flying the Kauai and the Kern, it sends the wrong message to partners. And when we do get funding, we will get funding again someday. We don't have to go try to reconvince them. That's how we've decided to operate this program. So the Feather River program, there was 3 big questions. Will it work in a rain-driven watershed? Will it work? Feather's one of our larger watersheds. Will it work? It takes sometimes 3 days to fly that sucker. And can we get those models and data in time to inform the B120? Those were the 3 questions, really, that we felt we needed to prove to ourselves, but more importantly, I think had to prove to the water contractors. And so some of the tasks that we identified, multiple snow data collection flights per year, getting that data ingested into ice snowbow, and getting those results then into WRF hydro. It was about $3 million a year for the last 3 years. I said that gives us 4 flights plus the 2 model. And State Water Project paid about $1 million of that. So that first task, can we get all these flights done per year? What really was involved in that? Timely collection, like I said. We're still at the mercy of Mother Nature. We want to fly today, and all of a sudden, we got 5 straight days of weather. Okay, well, that's not ASO's fault. It's not our fault. It's Mother Nature, right? But so ASO Inc. has a team of people that are just constantly staring at those weather models and advising us, hey, we originally thought the flight would be Tuesday, Wednesday. I want to move it to Sunday, Monday because the weather's coming in. So that's one thing that's been great. Processing all that information through all those folks at ASO Inc. They are snow and remote sensing experts. A lot of them came out of NASA or otherwise. They talk about snow like you talk about your favorite sports team or something. But it's amazing to hear them and listen to them and learn from them. I didn't know anybody did this stuff when I was in college, by the way. They didn't teach this. So all you students, cool stuff's waiting for you. And aligning them with snow course measurements because we need that validation. Well, one thing we learned through these programs is can't always do flights during the 10-day window to conduct snow course measurements. The weather won't cooperate. So now we have supplemental mid-month measurements thanks to our partners. We'll get out there and get extra measurements, maybe not at all 260 snow courses, but we'll get something. And can we align it with the B120? And all along, we want to keep State Water Project in line, explain to them. They rely on our forecasts, but we still need to explain to them what we're getting, what basis we're coming up with our forecasts, and so forth. This gives you an example on the feather. Top row is 2022, the 4 emissions. That was a dry year. You might be able to tell by the coloring. So really the peak was somewhere in February or March. Then there's 2023. Even in the feather, it was a heavy snowpack year. So the peak was around mid-April or so. And then this last year, which was remarkably average. Average years never happen. It did. So we had a peak right towards the end of March. But you'll see a rapid melt out last year. No doubt why LA was so dry. It stopped raining there in late April, early May. But we also had similar dry conditions in the Sierra. Just highlighting, so here's all the snow courses in the Feather River. And then you see pretty good coverage. Like we barely miss any. Sometimes if you see a blank one, it's just not scheduled to get measured that month. But again, you see the number of agencies that are contributing. Obviously, the Feather DWR is going to handle a lot of that, but Lassen National Park, ASO. So we get partnerships in dealing with this. So ASO did send staff out to get some supplemental measurements as well. Actually wasn't in the contract, so that was really nice of them. Again, can we get this fully calibrated ice snowbell model? So a subcontractor to ASO Inc. is M3 Works. They are experts at this. And then we got our own staff trained. So any model we're going to use, we need to check it, right? It's, I don't know, in your work, but in forecasting, it's like, I don't know, I got it from somebody else. Don't ask me why we're forecasting that. That doesn't fly. So we have fully trained up our team. They have their own in-house model, which we use to kind of check what we're getting from M3 Works. But they are the experts. So we love that they're providing all this information and guidance, and then we can kind of quickly check it, and then, have good conversations about it. And if we notice something, they're not afraid to say, yeah, good point, we'll adjust. Again, no egos. Wharf Hydro. Again, we relied on experts. So under ASO Inc., they have a modeling team now that is led by Dave Gotches, who just came over a year or so ago from NCAR. And Gotches was on the development team for Wharf Hydro when it first started. I call him the godfather of Wharf Hydro. Like he'll walk into I don't want to see the code, but he'll open up the code for me, and I just go, please, just go back to showing me cool graphics. So again, I feel like we've got some experts working for us, and I think that's really important. This doesn't have to just be DWR making a decision. We're not in a silo. We need everybody who has information they can share. These forecasts are unbiased. They are needed for key decisions. Throw the egos out. If somebody sees something, speak up. Let's adjust. And we also have CW3E, Scripps Institute. That's the Center for Western Water and Weather Extremes, down at UC San Diego. They built up a Wharf Hydro model actually to test out some of their weather and climate products and see if it was translatable into a runoff forecast model. So they're providing those April-July runoff forecasts as well, which is really neat because we're seeing how some of their California-specific weather models are doing. They're actually producing pretty good results. So even though it's in test mode still, we're happy to get that as well. And my dream is to get the climate weather experts at CW3E and the snow geeks at ASO come together and give me one model. But right now, I'm just letting them do their thing. A lot of bureaucracy there. So again, those are the 3 steps that I just talked about: the data collection, the ice snowbow, the Wharf Hydro. A little plug for that graphic over there on the far side. That's from our Snow Tracks website. I'll show you a slide in a little bit, but amazing work there from our team to bring all this data in, and it's out there for everybody to look at and take cool screenshots of. Again, I'm not going to go too much into this, but ice snowplow, as you can see, it's taking so much of these climate and hydrometeorological parameters in. It's baked into that model. Um, it's really breaking that snowpack into different layers. It's really, really taking in the effect of solar radiation, albedo, all those effects on the snow that I think have been largely overlooked for a long time. But in the last 10, 15 years, not so much. And then that interaction with the soil, we know is very important. Again, just cool graphics that come out of that even just at a glance, you can get an idea of what's going on. How much water equivalent change from one forecast to another? Where did it change? I talked about those elevation bands earlier. And then cold content. How cold is the snow? Snow's not, so the snow's warming up right now. And the warmer it gets and the warmer that snow gets, then it's riper to melt, right? So cold content and density are the two factors that we can look at, say, is this going to start melting soon or not? In the discussion yesterday, there were a lot of models about how warm the snow is getting compared to last year, especially. So we're a little concerned. Our state water project also helped fund a side project that allowed to look into the impacts from the fire scar areas in the Feather River. You kind of see the extent of the fire scars if you didn't know what a million acre feet or a million acres look like, and pretty much everywhere. So how is that going to change the Feather River, runoff for years and years to come? I don't know if you know this, but the soot that's on these burned areas, like you drive up 50 through the Caldor fire, that was what, 2 or 3 years ago. That soot will continue to fall into that snowpack for probably another 5 to 6 years. Dark matter on snow absorbs solar radiation, melts it out faster. So unless they go cut down all those trees, which they're not going to do, it's a lasting impact. Diving in on Wharf Hydro, again, I'll go over this pretty quick, but this is what we bring in, that information from Ice Snowbow. Again, it's such a holistic watershed model, and it's climate informed. So when we put out a forecast, it's looking at the weather 6 to 10 days out or whatever. So it's informed by the near term weather forecast. And, Channel 3, and they're going 7 days out from now. Weather forecast is good for about 5 days. Most meteorologists, I think, would admit that to you. But that we're getting there. We're getting closer to that 5 to 10 days and getting confidence. My daughter called us the other day and said, I'm trying to plan something for a school event. What week in March and April will it be dry? Yes. Yeah. But these models can take in different climates and weather forecasts. National weather model goes out a whole year if you want to believe it. So again, you can see all the parameters there, and when you think about those equations and those 3 variables, we've come a long way. A lot of this is still really being tested out in terms of the data collection, right? The models can say all they want, but if you don't have the good data collection, you're garbage in, garbage out. So again, going through that modeling process, the direct insertion from ASO. So Wharf Hydro doesn't need ASO. It'll predict what the snowpack is and go wild. They jam in ASO and they say, no, this is what it is. And in some watersheds like the Tuolumne, ASO is within 3% air. It's amazing. Now that's a fully granitic watershed, but the error is really, really low with ASO. So, interrupting that model process with something better is what we want. So then they've got to reinitiate the conditions and get us an updated run. Again, this is from our SnowTracks website, so really easy to remember, snow.water.ca.gov. Really original there. This is just one of many dashboards. So this is taking the Wharf Hydro results, but actually comparing it to the RFC's forecast, our Bulletin 120 forecast, other forecasts that we can dig up there that are publicly available. We're not so egotistical that we think our forecast from the B120 is the best. It's the best that we can put out there. But we want water managers or whoever to be able to look at what is all the guidance out there. What are the models generally converging? That's good. Are they not? Okay, time for discussion. So just getting this information out there. There's so many other dashboards on there. Really, I think you can still do the 3D view on there too. You can take a watershed and spin it around. So I like to do. Okay, so the outcomes. Significant corrections were made to basin-wide sweep every 3 square meters, right? So obviously we're getting a much better product. There's so much variability in that snowpack and the albedo that this is really honing in some of that, reducing some of that error. Capturing snow water equivalent estimates in that rain snow transition zone, which is huge in California. I mean, on average, we think that's 5,000 to 6,000 feet in elevation. This year it's been more like 7,000 to 8,000 feet elevation. But in a warming climate, it's going to keep marching up the hill. So that rain snow is a big deal, right? 260 snow courses across the state, but they're not in the most remote regions. The original snow courses were put in open meadows because they needed an open view. They didn't want tree intrusion. Meadows weren't underwater back then. But they were also places they could get to. But the Sierra Nevada is vast and it's full of remote peaks and things you can't get to. And those are usually the highest elevations where in a drought year, the snow's still up there. So if we don't know the snow's there, we might underestimate how much water is actually available in a critically dry year. So ASO covers that for us, transition zone and the modeling improvements as I talked about. And there's just a graphic that kind of shows you the in situ measurements, the manual courses or whatever. But then here came ASO, and like you can see that the lowest bullet point or dot there on the blue line, it significantly said, no, you don't have as much snow as the manual courses would lead you to believe. The very first flight we ever did in the Feather 3 or 4 years ago in February, we had a heavy snow, couple weeks of snow in December and January. There's so much optimism. We're going to break out of the drought. This is going to be great. ASO flew and they called me. You don't have as much snow up there as you thought you had. It happens to be on all of your pillows and all of your snow courses. Not much else. And it's funny, but we put snow courses where snow fell. Okay, well, yeah, good. We place the snow courses in a good place, but it's misleading sometimes, right? So, any state water project, you know that thing you're paying for? Well, sorry, don't have as much snow as you thought. Improved understanding of the physical properties. Is it ready to melt? Are the soils soaking up all that good snow? Where is that snow? What are the ablation patterns and accumulation patterns? How have they differed? That's going to be a long-term study. You know, we're still new in this, especially in the Feather, but it's got the potential to give us some ideas. Is it helping the old forecasting system? You bet. We get pillows and courses that don't get measured or go out all the time. We can fill in data gaps with this. We can get a reality check on all kinds of stuff from this. So we can't plug it into the old equations, but it can inform us where we're missing information or not thorough. We want to keep that legacy going for a while because it's what we know. Recommendations, we would love the full 8 flight per year. As I said, we need that mid-January one to initialize model states. Okay. That leaves you 7 flights. We want one in reserve in case we got to refly in the summer. But now we have 6, what I call operational flights. February 1, March 1, April 1. Now we're down to 3. 3 in the snowmelt period, including 1 that says you got no more snow on the ground sometime in June. So 8 seems like a lot, but when you break it down into how our seasons go and how snowmelt and water runoff goes, it actually makes a lot of sense. Right now we're 2 to 4. We're going to be a little bit less next year, but we'll keep going. We don't want to get rid of those in situ measurements. In fact, we'd like to expand. That's harder to do actually than get more flights, but that is often a question. This is going to get rid of all those. No. We need we got snow courses go back to 1909. Do you think I want to get rid of that? The best climate data in the Sierra Nevada, besides maybe rainfall data at Donner Summit, are our snow courses. You go look up climate records in California older than that. They're going to be in Sacramento. They're going to be in Fresno. They're going to be in Los Angeles, maybe not even Los Angeles, San Francisco, where the population was. Our best climate records in the data in the Sierra Nevada are our snow courses. Don't want to get rid of them. Want to continue to enhance our models. We want to continue to develop our staff because we need to fact check this. We need to know if it's true or not. We need the investments with our partners that are doing meteorological and climate research. It's all tied, right? And continue research, keeping out ahead of us in the models and the sensors and everything else, especially in post-fire. So the conclusions here, this was what we were presenting up to the City Water Project. It definitely is needed in the feather. It's extremely accurate. We felt like we've seen improvements. As I've talked about, we can dive in so much more. We can understand the physical processes. We can decipher a lot more, and we can inform reservoir operators in the thick of a really big flood year, in the thick of a drought, more than just, well, the median forecast is this number. That's what we think. We can actually provide a little bit more context of what we're seeing and why. In forecasting, it's not who's right. Everybody's wrong. It's can you explain where that error is? You're not trying to say I know how to get around that error. You're just saying this is where all my uncertainty is. Future weather is a given. We need to go more deeper on the uncertainty in the other parts of the watershed of where we're not sure. And reservoir operators, water managers need to hear that. So I think we answered the questions all yes. Does it work? Yes. Can it work in that big of a watershed? Yes. And can we inform the B120? Yes. I think that's it. Bonus points, if anybody knows where that is. So it's Julie.
From Shasta.
Whoa.
North on 5.
Oh, that's not northbound 5, but you're very close. Okay, Mount Shasta's.
Which direction Shasta to the right?
To the right.
You? That's like you. Yeah. Good job.
That's Everett Memorial Highway going up to the old ski bowl. That's Mount Eddy and the Trinity Alps in the background, and somewhere down there is the Sacramento River. So not the big. My favorite watershed.
Me too. Middle Feather is my favorite. Middle Feather is my favorite river.
Middle Feather's okay. So I don't know if I went way over time.
Well, you're doing great.
Oh, I do, right? So I think we're good for questions.
Yeah, absolutely.